Well, greetings out there in YouTube land, and welcome to today's video, which features a really early Gibson BR-1 amplifier. They were made in the post-war period from 1946 to 1948, and it was the top of the line post-war Gibson amp at a fat and sassy $190. Okay, which was a ton of money. You could probably buy a really good used car for that amount back in 1946. It supposedly has 15 to 18 watts of output, featuring two 6L6s, a 6N7 phase inverter, and a 6SC7 preamp tube. Okay, with all of that historical information behind us, let's start to do the traditional once over externally and internally, and then let's see if we can't tune it up for the owner. The grill is perforated aluminum, which is really pretty but dense if you sneeze on it, and it's embellished with the Gibson post-war logo, the G that's sort of semi-reclining, and then if there's any doubt about the origination of this, you have Gibson up here in gold decals across a sort of a brown leatherette material. The handle is pretty well shredded, as you might expect on something that's 73 years old, and we see screws here in these metal straps, which usually indicates that the rivets have been drilled out and the handle's been changed, but I'm not so sure. I tend to think maybe they actually use screws because they're perfectly matching, and this handle doesn't look like it's any sort of a replacement. Okay, notice there's some discoloration around the handle. We have that leatherette that has held up beautifully here. When you see the right side looks just about like new. We've got a little bit of road rash here on the corners and all of the cabinet, but I think for 73 years old, it's in spectacular condition. All right, let's turn it around and take a look at the rear. Okay, we have a really nice looking cream and aluminum control panel, and also look on these knobs, which appear to be like bakelite, but there's like a little celluloid indicator on each knob that's still present. That's going to be fairly rare. Okay, the typical on-off switch and pilot light. Let's see, we have instrument and microphone inputs. Model BR-1. The serial number is only 4 digits, 2662. And we see that we have the microphone volume control, the instrument volume control for the instrument input, and then a tone control. Now, up here is the only ventilation for the tubes, and that, according to an article in Vintage Guitar, is a shortcoming in that the tubes would tend to overheat. Okay, that's, you got to say that the grill is in gorgeous shape. It's that old wrinkle paint. It's perfect, but really it wasn't a great design, and the tubes tend to run a little warm. Okay, it's got a full rear cover on it with a little place down here to retrieve the cord. Let's pull the lower back door and take a look inside. Alright, I have the lower back door off. You see that that really nice wrinkled paint continues all the way down here and is covered really by the back door. It looks like another brace has been created here. I had read that they have a brace to support the really heavy electromagnet here for the electrodynamic 12-inch speaker. And looking at the crude woodwork here, I have a feeling this was fabricated long after the amp was built. And you can see how it would support that heavy magnet with that big screw going through the center. And then they whipped up another kind of a cleat down here that apparently was missing. Okay, so we'll have to check inside here and see what other surprises we have awaiting us. I'm seeing a kind of a zip cord here that you know is not up to the challenges of an amp like this. It's going to draw a few amps of current. But let's get some of this stuff out of the way and see what else is waiting for us inside. Oh, and look what came to greet us. A nice electrolytic capacitor is hanging down here out of the chassis, and a big old stout transformer back there. I'm going to guess it's the output transformer, but we'll have to see. Let me see if I can move some of the lumber here so that we can get a better look inside. Well, I decided it might be easier just to extract the chassis from the case, so I undid the upper screws, and here's a nice touch. The electrodynamic speaker has a plug that plugs into the bottom of the chassis, so to disconnect the speaker, which is kind of a hassle sometimes with electrodynamic speakers, we just unplug it and lay that cable down in the bottom. Now I'll go ahead and try to tug this massive boat anchor out of the cabinet. I just had to stop while I'm pulling the chassis out, which is not coming out very easily. It's like opening King Tut's tomb and you look inside. I have a feeling this chassis inside here hasn't seen the light of day in a while. There's looks like rodent residue and nesting and God knows what kind of stains, but it's all there and it seems to be reasonably unmolested, which I guess is more than you can normally expect on one of these. So let's go ahead and finish pulling out this chassis. And that process is made all the more difficult by the fact that this may be a 5U4 rectifier, but it's about 1.5 inches taller than it should be, and it won't clear the cabinet. And there's really no good way to get in there to try to remove it. I'll have to figure something out. But who would have dreamed, huh? Well, I was able to reach in from underneath, come around the back, and lift the tube out, and we see that it is indeed a 5U4 rectifier. It just happens to be one of the very early tall globe or Coke bottle style, so I'm going to have to get a smaller version of this to put in the chassis so that it can be removed a little more easily. Okay, get the chassis out, and this amp came from Chicago, so that's corn country. So as you can see, the rodents there have the finest possible corn at their disposal. There's some more at the bottom. Okay, so these are well-fed rodents. Yep, 4 out of 5 mice prefer DeKalb corn. All right, look at that massive 12-inch electrodynamic speaker. Very impressive. There's its output transformer, so I'm not sure what that big rascal is hanging down from underneath of the chassis. We'll see. Got the chassis over here. Look at the size of the power transformer. And the tubes, I'm going to pull them all out and clean them up, and also clean the top of the chassis, get the God knows what off of it. Okay, and then, all right, I removed all the tubes. The only one with a external marking as to the identity of the tubes, the 5U4, the rest have the tube identity actually marked on the socket itself, which is always a nice touch. We'll take a closer look at the tubes in just a minute, but for now we have a 6SJ7, a 6SC7, and a 6SN7. That pretty well covers the almost all possibilities on the 6S series. We got 2 6L6s here. They're the regular like G or GB style, and of course the 5U4 rectifier. You're going to hear some wind in the background because it's windy outside and I have to keep the window open for ventilation. But I use my engine hoist, flip this jewel over, and look at the beautiful wiring. Everything bundled together, different angles. Look at that. I guess it's not really an eyelet board, more like a terminal board of some sort. The mother of all filter chokes. It only has 2 wires, but my God, look at this thing. It's like the size of a cinder block. Okay, and then this is what has my interest, is this shield panel here, and I lift it and I don't really see anything under there that is any different from what I see to the right. Maybe it's this is the preamp section or something and they shielded it to cut down on the noise, but as you can see, it is unmolested. Other than that, you know darn well that it didn't leave the factory with that capacitor hanging out in the breeze. But otherwise, just spectacular original condition. Okay, and I believe original filter caps, if you can imagine the shape they must be in, although I've plugged this thing in and it doesn't hum. That's just astounding. But anyway, I think these will have to be attended to. You know, when I see bundle wiring like this, so neat and hand-tied, it makes you think of military spec electronics work. Think about it. This is of just, what, a year or so after the Second World War, and I'm thinking electronics technicians were being hired by civilian businesses about this time, and I bet you that Gibson picked some up and they just continued their very fastidious type of wiring. Look at that. It's just beautiful on the Gibson chassis. Then when we look over here to the right, you see that nicely positioned socket for the speaker plug. Just first-class work. Nice engineering, great layout. This is back when people really cared. When you got your money's worth out of an item, even as expensive as this was back in 1946 or 7, it looks like it's expensive. Okay, nowadays things are expensive and you look in and there's no justification for it. Sadly, at some time in the past, when the chassis was pulled out and the 5V4 was bent back as it was earlier, the locating prong here on the bottom of it was broken off. So for two reasons, this will have to be replaced. And I went in my stash and found a nice 5V4 GB, which is considerably shorter and will clear the cabinet when the chassis slides out. The reason you don't want to use especially rectifiers with broken locating prongs like that is if this is turned in wrong, it could create a dead short in your power supply with really unpleasant results. So when you see broken prongs like that, I think it's time to replace the tube. Well, I vacuumed and cleaned the inside of the cabinet. I noticed that number 1 under there. That's always reassuring. Okay, now it's time to start on the chassis, and I also noticed, look at how this electrolytic capacitor is leaking, literally, its guts here, all over the outside of the chassis. So there's no doubt this electrolytic and this one will have to be replaced. There's also a couple cathode bypass caps that are electrolytic and are lurking here under our terminal board. Okay, it's going to be difficult to come up with a place to put those electrolytics. I was thinking of maybe attaching a terminal strip right here and so that they are tethered to something. Okay, so I'm going to have to stop for a little while and figure that out. And meanwhile, I'm going to try to clean the top of this chassis, which is pretty much of a hideous mess. Okay, now we're all cleaned up down to that really nice wrinkle finish on the chassis. I see there's a very frail little ground wire that's broken. I'll have to resolder that. Then it's time to flip this over and start the recapping procedure. Now, to mount the capacitors and be sure that they're held securely, I have attached 2 parallel terminal strips here right in the area where the original filter caps were located. Now I'm going to run the new electrolytics across this gap and then connect the wires to them. There are the 5 new electrolytic capacitors all wired in. I shortened the leads so there's no slack, in keeping with the really nice wiring in the rest of the chassis. Now if you look at the filter choke here, this wire runs over to this electrolytic cap, and then after the filter choke it goes up here to the speaker and then comes back to this electrolytic cap. So I don't believe this one is necessary. I think it was tacked in maybe to cut down on some hum. I'm going to remove it and check and see how things work out. Our suffering though is not over yet because as you can see there's 2 electrolytic cathode bypass caps lurking underneath the terminal board. And I'll tell you that once the terminal board is wired in place, it just doesn't lift up and get so that you can gain access to these. So the positive end connects to this terminal, and this positive end here connects to this terminal. So what I'll do is cut them loose, and then I'm going to wire new cathode bypass caps up here from plus to minus on top of the terminal board. These old caps will be left underneath, but they'll be disconnected. I got kind of lucky because this one was here on the end, and I could lift the board up just a little bit to unsolder one end and cut the ground at the rear. So now I can install the new cathode bypass cap underneath out of sight. Okay, there it is under the board. It's connected back here to the ground, and up here at the front I'm going to have to connect the two wires that go to that electrolytic cap, and then I'll be able to solder both terminals. Now that second cathode bypass cap has been completely disconnected from the circuit, and the new replacement has been installed. You know, I love working on these old amps, but I got to tell you, sometimes the really archaic designs are nightmares to work on. Look at this in here. For just replacing the power cord, it has to be routed through from behind and then somehow wired here to the fuse and on-off switch. No fun. Okay, the primary wiring is now correct. The hot wire goes through both the switch and the fuse before going to the power transformer. The neutral return AC wire connects to the other transformer primary lead right here, and then the ground wire comes around and is grounded on the chassis at the same point that the center tap of the high voltage winding of the power transformer is grounded. Okay, I put the shield back here over this part of the terminal board, and as you can see, I think it looks pretty nice right now. And it's ready to be tested. So let me flip it over, clean up the tubes and install them, and we'll see if it works. Before cleaning and installing the tubes, I thought it would be good to clean and wax and polish the control panel, and I think it turned out probably pretty much the way it looked when it was new. How about that for a gorgeous pair of 6L6s? When was the last time you saw a tongue saw 6L6 that was made in the United States? Wow. Well, there you have it. All the nice clean tubes are into the freshly cleaned tube sockets, nice clean chassis, really pretty polished up control panel. It's all ready now to slide into the cabinet, plug in that electrodynamic speaker, and check the bias on the 6L6s. Alright, it's time to check the bias here on the amp, and I've installed the Eurotubes probe in series between one of the 6L6s and its socket. Now we'll turn on the amp and wait for the values to stabilize, and we'll see what kind of plate dissipation we have. How about these for some readings? 146 plate volts, 70.4 plate current in milliamps. Sort of upside down, isn't it? This should probably be close to 3 times higher, and this should be about 50% lower. Okay, let's try to figure out why this is the way it is. And if you think that the Eurotube's biasing probe is malfunctioning, I rechecked manually and it's right on the money. Very, very low plate voltage and fairly high plate current. Okay, let's look at the schematic and at the chassis and figure out what's going on here. And I think we need to direct our attention to this big ballast resistor that's been installed here on the chassis at the factory with riveted mounts, and it's a 20K high wattage resistor. Let's see if it's on the schematic. Sure enough, there it is, 20K. They don't say anything about wattage, but it's a bleeder. It goes straight to ground, and it's going to reduce the B+ that is delivered up here to the center tap and to the plates of the two 6L6s. let's measure the voltage drop across that 20K resistor and see just how much voltage reduction it provides. Okay, things have stabilized pretty well here, and you see the 150 plate volts, 73 milliamps of plate current, and the voltage drop across the resistor is 176, say 177 volts. If you add that to this, what are you going to get? 322, 323 volts, which is sort of a fairly normal B plus for one of these older amps. So it seems obvious that this bleeder was put in place to lower the plate voltage by about 180 volts all the way down to around 154, and then to operate the tubes at a fairly high plate current. This is unusual. I've never seen this before in an amp. Maybe some of you have, but I never have. Okay, so this is most unique. And what will be interesting to see is how this amp sounds, because it's performing exactly the way it was designed. I see no reason to try to change it. I could eliminate the resistor and run this up to 325 or so, and then this would come down. But you know, that's not what we're here for, to change the basic design of vintage amps. Let's let it operate the way it was built and see how it sounds. Also, when we calculate the plate dissipation based on the two measurements that we just got from that 6L6, we see that it's around 12.2 watts, which is very conservative, very acceptable for a cathode biased 6L6. So the tubes are not being harmed, even though they're being operated in sort of a very unusual manner. The plate dissipation is well within acceptable limits. Well, it's time to hoist this behemoth up here into the cabinet, and the more I look at this light-colored lumber that's used in these two rails, the more I think it's probably completely original. I don't think anyone replaced it. I don't see really why they'd have to. And I believe that this just testifies to the fact that these cabinets were handmade, maybe even at Gibson or someplace down the street, just from lumber. Okay, it's strictly hand built. This isn't from some big dedicated cabinet factory. Okay, these things were built sort of hand by hand, one at a time, which sort to me kind of adds to the enjoyment. You can see under here the wax that has been dripping from that filter choke, a testimony to the leaky electrolytic filter caps that it had. All right, we have the amp chassis secured back in the cabinet, speakers plugged in, new 3-wire cords coiled up in the bottom, and it's time to install the back door. Okay, now we have the back installed on the mighty Gibson BR-1, and it's time for Jack and Ollie to plug in and strum a few tunes for us. video, since this was a relatively short video, we're going to have a second feature here in which we're going to check out the cutest, neatest little compact tube tester you've ever seen in your life. If that sounds interesting, then stay tuned. Well, greetings and welcome to today's extra feature. Today we're going to take a look at the snazziest little tube tester I've ever seen. This one was donated to us along with that Gibson Tweed amp and the Lessman amp by a viewer named Big Dave. So once again, we need to say thanks, Big Dave, for contributing to our channel and giving us some really great equipment to feature in videos. Okay, let's take a look at this beast. You can see how small it is when you compare it to my hand. It's the smallest one I've ever... let's open it up and check it out. Alright, all the paperwork up here, we'll take a look at this and the little tube handbook. But look at the condition of this gem. It's just beautiful. It's perfect. It was also made in about 1941 or 42, okay, just before World War II. And if you notice, it has all sorts of tube bases, but no 9-pin tube bases for 12AX7s, because at the time this was built, 12AX7s were not released and sold to the public until 1947. So it was 5 years after this. So that's one shortcoming. You can test your 6L6s, 6V6s, and all of the 6S series tubes here, also your Loctals, and all different types of unusual tubes, even 4-pin, but not the miniature tubes, like the 12AX7s. Let's take a look at the controls. This will be the on-off switch. And we're going to get a little shadow here that we want to align with that red line so that our voltage being supplied to the power transformer is absolutely right and calibrated properly for the machine to give us reliable results. Here, look at all the different filament voltages, down to 2 for the really early, the O1As and stuff like that. And over here are ballast tubes. Load, which we'll adjust for each specific tube. Element, which is something we'll see when we're doing, when this is on S, this is for testing for shorts. And then we'll go through all of the elements and we'll look up here at this neon bulb, and if it stays lit in any of these positions, then we know we have an internal short in the tube. Then after testing for shorts, we'll go to whatever letter our paperwork up here tells us. Okay, we're going to test a 6V6 here in just a minute, and you're going to get a chance to see exactly how it works. We've got the real standard tube tester type of readout, bad, questionable, and good with, I guess, what, 0 to 100%. This is probably the emission testing, the ability of the tube to amplify, as we'll see on the 6V6s. And also, I have a really good Hickok 600 tube tester. So what I'm going to do is test the tubes in it, then we'll test them in this. And we'll see how this one agrees or disagrees with the Hickok. Okay, so I think we'll be able to evaluate its function very accurately and get a really good idea how these early tube testers work. Now, when I first got this, several things didn't work. First off, the bulb didn't work here in our voltage setting module. And number 2, it had a really flimsy, crummy power cord. And number 3, there was one old waxy capacitor in there. Now, don't worry, I'm going to open it up, show you the innards, and we'll go through all of those repairs in just a few minutes. But I just wanted to introduce you to the machine. I didn't want to make the video unless it functioned properly, so I had to make it do that. And now that I know that it does function well, I will show you how I repaired it. Okay, the power cord resides in this clever little compartment here. Now we have a 3-wire power cord. And also for you old radio guys, you'll remember how some of the tubes have a plate electrode up on the top of the tube, and this is to grab onto that electrode, okay, that will allow you to test those really early tubes. Let's take a look at some of the booklets that came with it and literature. Look at that, 10 cents. And what this is sort of just a general booklet telling all of the values that you should find on these different tubes. It's sort of like a little tube handbook, okay, so it's very useful. This will be a nice one to have. And in here is the literature that helps you use this tube tester. This is special for ballast resistors, which we really don't care about. But down here you'll see that for each tube that you want to test, you'll look it up on this sheet, and it will tell you the settings for A, B, C, D, and S. Now over here it will tell us then how to set A, B, C, D, and how we're going to test for shorts, and it's almost always an S position. So this will be our key then to making all the settings right on our tube tester so that we can test our 6v6s. Now let's find the 6v6s on this sheet. Alright, here we have the 6v6, and our settings will be 6.3, 26, 2A. 6.3 filament volts, 26 for the tube load, 2, and A. Okay, now that will be the way to test the emission of the tube. Also then for shorts, it tells us then that we're going to test using position S. Okay, so let's start off testing for shorts. We'll plug a 6v6 in up here, we'll test it, and we'll see what our little meter says about it. Alright, I've plugged the tester into the current limiter, which will reduce the voltage a little bit, but we'll adjust right here for that slight reduction. And I've put a 6v6 in here that my Hickok tube tester says is rather weak. Okay, in fact, I think its emission was only around 450, which would make it actually too weak to use. Okay, so let's turn on our AC. You see how it lit up. Now the shadow is just to the left, just a fraction of an inch to the left of the red line. So I'm going to crank up the knob. You notice the shadow just moved over a little bit, and now it's behind the red line. So we're set, and we're going to test for shorts. I put the selector in the short testing position. Now watch the neon light as I switch through the different element positions. Okay, it's going to flash every once in a while, but we're looking for the light to stay on, and that will tell us that we have a short. Okay, I'm changing positions. They said that the flash in the instructions is perfectly normal, but that a sustained light on the neon bulb was indicative of a short. Okay, then coming back, I'm not seeing there a little flash. No sustained elimination. So we don't have shorts. So then we move over here, which sounds like we're at the nudist colony, I guess. But over here then we'll turn back to our A, which is what our little booklet told us to, and we'll watch as the needle will start to rise as the tube emission will be measured. And after the tube is warmed up, we'll see that yes, it has some emission, but it is too weak to be used, which is pretty much what the Hickok tube tester told me. Okay, let's try another 6v6. Alright, our second tube here will be a Sylvania 6v6. It's a military spec tube, And the Hickok tester said that the emission was 1850, which is plenty. Okay, this is a used tube, definitely not new, but the emission makes it very usable. Let's plug it in and see what this tester thinks. Okay, it's in place. We will turn on our AC, and it looks like we're in pretty good shape with our shadow under the red line. So let's let it warm up and see what kind of reading we get. There it goes. And sure enough, it's a very good usable tube, which is exactly what the Hickok tube tester told me to expect. All right, let's try one more, and I think that we'll have to agree that if the little tester here agrees nicely with our Hickok, that it is a good, reliable tester, at least for 6v6s. For a third and final test, let's try a 6L6 GC. According to our Hickok tester, this tube is marginal. It's probably usable, but it is rather weak. It has been used. Okay, here it is plugged in. The settings are the same as for a 6v6. Okay, so I have all the settings in place, and sure enough, it's right here, right at the edge of good. Okay, it is sort of a marginal tube as far as emission goes, but in a jam, I would say you could use it because it's right there, right bordering on good. So once again, our little tester agrees with the Hickok tester as far as emission, and I think that gives me the confidence that I can use this routinely to test especially output tubes. Okay, so I hope you liked that. I hope you enjoyed it. You'll keep an eye out for these little tube testers, and also now let's take it apart, see how it was fixed, see what it looks like inside. Well, as you can see, the inside of a tube tester, even a simple small one like this, is incredibly complex. How do you like to have to troubleshoot this switch? Look at that. Okay, the things that I see that need immediate attention: replace that waxy cap. Let's remove the shroud and that voltage adjuster. I think it's just that the bulb is burned out. Replace that bulb. And also let's install a 3-wire power cord while we're at it. Okay, here's that voltage indicator, and you can see there's the needle, and when the light bulb's in here and it lights up, it casts a shadow on that screen with the line in it. And the thing that might be wrong with it is that the socket is split. Now it seems to me like the bulb should still be able to make contact at the base and here, but I'm going to close this up, and we'll try it again. The bulb itself is fine. It's not burned out. So let's see if we can get this to... Okay, to close that crack, I used the simplest method I could think of, which is to wrap a fairly stout wire around it, twist it, and close it, and sure enough, this threads in now nice and securely. So let's try the unit again and see if we can get that bulb to light up. Okay, I've got it plugged in. I'm going to turn the rheostat, and sure enough, the bulb lights up. You can see I can turn it off and on. It's not exactly a beacon of radiance, though. It may be enough to cast a shadow on our little lens here. I guess I'll have to put it back together to find out. And if it isn't, then it all has to come apart again, which is kind of depressing. But anyway, it is working. So let me put it back together, replace that power cord and this cap, and then we'll see if it's in good working order. Alright, the work is done. The 3-wire power cord has been wired in. The chassis is securely grounded. That 0.1 microfarad cap has been replaced, and now the bulb works in the voltage adjustment module. So let's flip it over and see if it works. Well, I guess that's about it for this little extra feature on the professional radio tube tester model 1185, made probably around 1940, 1941, just before World War II. I hope you enjoyed this little extra feature, and I'm going to try to do this again in the future with unusual, kind of ancient, vintage equipment like this. Try to get it operating and then test it and see how well it works. Okay, I hope you enjoyed it. One last thing I had to do here is to get a proper handle for this. I know that some of these luggage handles are available that will loop through these riveted loops here and allow us to carry this device with a handle as was originally intended. Okay, so with that, we'll say farewell, and until the next video, thanks for watching. Well, I guess that about does it for this video on the mighty 1946 Gibson BR-1 amplifier. Who would have thought that a pair of 6L6s could operate at 150 plate volts and sound so good? One of the miracles of ampdom. Wanted to express my thanks to all my Patreon patrons and PayPal contributors for keeping us on the air, advertising free for another month. Any of you who would like to join them can just check the video description for links that will enable you to do so. Also, if any of you would like to donate gear to our channel that we can use in future videos, please contact me and we'll make arrangements for that to happen. Meanwhile, we appreciate you subscribing and the time that you spend watching our videos, and we look forward to seeing you again in the near future. Thanks for watching. Bye for now.